So welcome to SQL Server 2017, the Fast and the Furious. Was anybody here last year? I was here at Ignite talking about it just runs faster. Anybody here? Raise your hand. Were you here for that session? This is the next evolution of that series. Instead of it just runs faster, it's the Fast and the Furious. My name is Bob Ward from Microsoft. Welcome to this session. You know, if you're here today and you're new to SQL Server, like you've never used this product before and you're wondering, does this thing perform? I'm using a different database vendor and I'm just wondering if this performs to my needs. Or maybe, you know, you're a Linux developer and you're wanting to SQL Server on Linux actually perform to your needs. Or maybe you're looking to migrate to SQL 17 and wondering, is it even worth it? Are there compelling reasons why I should make that switch? Or maybe you're a database expert. You're like, I know all this stuff. And I just want to come here today to kind of confirm, am I doing all the right things? Am I making all the right choices? And then finally, maybe you don't even need to get faster. You're like, my performance is pretty good, but I'm kind of struggling to keep things fast and keep things tuned. I hope that if you're one of those folks, that over the next 75 minutes, I'm going to provide information for you and some demonstrations that are going to help you make those decisions. A couple little housekeeping items here. One, I'm a big believer in people having my deck and demos right away. So if you go to this website, aka.ms/BobWardMS, literally right now, this deck and the demonstrations I'm going to do are already available to you. You can also get the deck on the Microsoft Ignite website where you download your decks, but please take a look at them and download them, use them all you want. Second of all, pretty big room today, which I'm pleased to see everybody here. Going to be tough to take questions in the middle of the session to try to get through all the content. So I hope I have time at the very end for you to come up to the mic and ask questions. My experience has been that when you get to the end of your session and you say, okay, it's time for questions, a mass exodus of people leave the room going to lunch, right? So anyways, we're going to plow through 75 minutes of content here, and we'll try to have questions at the end. But here's my promise to you. I will answer every single question that you have. Today at 5 o'clock at the booth down at the Expo Hall for SQL 17, I will be there for an hour. I'll answer all your questions. If you tweet to @BobWardMS on Twitter, I will answer your questions. If you email me at bobward@microsoft.com, I answer your questions. And I will create a blog post after this event with all those questions so you can all see them if you don't hear them in a shared situation like today. So with all that said, let's plow through and start talking about this topic. Hey, if you're going to talk about performance, you better have some numbers. And we have numbers. I think numbers that matter, though, whether it's numbers or performance on a laptop, whether it's world record-breaking benchmark numbers, or whether it's pretty amazing numbers we can do in our lab. Anybody attend the last session, Deep Dive, SQL 17 Deep Dive over at the Hyatt? Did you go over there? Did my colleague Travis show you a neat scan of 180 billion rows in 20 seconds? That's actually pretty cool. So, you know, but some of these numbers matter to your workloads. And so you're going to see these numbers kind of show up today throughout this session as it applies potentially to what you might use for SQL Server. This is kind of the agenda of what we're going to do. We're going to spend some time talking about SQL Server 2017 and some of the features that we've added that are going to help from a performance perspective. And then we're going to deep dive into some of those throughout the session. And I kind of have this theme that I'm using in this series. One is that SQL Server is fast right out of the box. With very little configuration, almost no configuration, you can get speed that might surprise you. You can be faster than you think. We're going to run fast on Linux. May surprise you. You actually can get faster by doing some tuning and some configuration, some changes to SQL Server to get a boost to your performance. But again, you know, maybe you're okay with speed, but you got to keep fast. You know, you're great when you deploy, but as you move along in your application lifecycle, things slow down a little bit, and you're not sure how to keep things tuned. I've got a really neat, exciting demo to show you for that. And then finally, it's my contention that SQL Server is the fastest database everywhere, whether it's on the planet or in the cloud. And I'm going to talk about that towards the end of the session. So last year I was here, I said at Ignite, I had a series called SQL Server 2016, It Just Runs Faster. Did a nice blog series on that. I presented that talk some 25 times all over the world. And it was all based on this premise, that SQL Server 2016, we made changes to adapt to modern hardware. We made things default. We partitioned things. We made things larger, run in parallel. And we tried to make sure we avoided this concept called reverse scalability, where you would actually put on SQL Server on a high-powered hardware machine, start pushing it, and things would get worse, not faster. And these are the kind of things that we did. So if you're in this room today thinking, well, I'm not on SQL 17, I'm not ready to go to that, but I'm on SQL 16 or moving to that, take heart, because all these features that we've added in 16 all apply to you. And we've actually tried to build on this foundation in SQL 17. And then if you're looking to migrate and wondering how do I do that, what are some of the steps I would do, not just to do the migration to like a SQL 16 or 17, but what are the post-migration steps? We have a new migration guide. And in my slide decks here, when you look at them, I've got all these different URL links for you to click on and look at different reference material later. Take a look at our migration guide. It's got good information about how to make the migration and what to do post the migration to make your SQL Server perform to its maximum capacity. What about SQL 17? So in the spirit of SQL 16, we actually made some changes to keep our engine tuned. These specific changes you see in front of you are not one that are going to make the headlines, right? These are behind-the-scenes changes that could actually boost performance of SQL Server in your database. And I plan to do blog posts, just like I did in SQL 16, it runs faster, on each one of these topics. But just to give you kind of a flavor for it, indirect checkpoints, which is a recovery feature for SQL Server to actually get a more accurate recovery of your database. We found in some situations it wasn't scalable to use that feature, and so we made it scalable and made changes to do that. How about improved scan and read-ahead algorithms? We actually found that we, in some cases, were being a little too aggressive when we would do scans of tables using read-ahead. And so we kind of changed our code a little bit to make it more dynamic, and we increased the size of the read-ahead up to 4 megabytes, even at a single read-ahead operation. We went after spin locks, and you may not know what a spin lock is, but a spin lock is a structure, a protection mechanism inside SQL Server at a very low level to protect certain data structures. And it's a great situation where when we actually push SQL Server on faster hardware or make optimizations, we uncover concurrency scenarios or scalability scenarios we need to improve. And so one simple example was, we found, after optimizing SQL Server as much as we could on high-powered hardware, that we were going after and checking to see if you're running in a contained database every time you ran a procedure. Well, you would not normally see this problem if you're running maybe an app that does not on a high-powered hardware system, but if you are, you might run into it, and you wouldn't know it. But we found it through a benchmark test. And we went and eliminated the need to even go get this check for a container, which resulted in a spin lock problem. So again, some of these are the different types of internal changes we made to SQL Server, all built in with SQL 17 in the product, help your application get better. But what about the headlines? What are the bigger features that you might want to know about? Well, maybe you've not heard, but we run on Linux now, which is actually pretty cool. And we run fast on Linux. In fact, our #1 benchmark that we produced for SQL 17 for TPCH was running on Red Hat Linux. Also, we have some features we're going to talk about to keep you tuned, adaptive query processing and automatic tuning. And then one that's very interesting that I'll stop right now and mention, because it's at the end of the deck, and I don't want to miss it, is read scale availability groups. And I'm here today to announce, if you've not seen it, that you can set up read scale availability groups without a cluster, without using Windows clustering. So you don't get high availability, but you can set up secondaries to do read-only workloads and read scale across availability secondaries without setup Windows clustering, and that's new to SQL 17. There's some other things that are interesting. Maybe you've heard of this graph database type. We have a customer that actually went through a process of, instead of using Titan as a graph product with their product, moved to SQL Server Graph Database and observe up to 5 times faster performance by using our built-in Graph Database functionalities. How about Query Store? If you've not seen Query Store as a feature of SQL Server in SQL 16, we now have added weight statistics. So now you have the ability to take a given query in Query Store and get an end-to-end performance picture, not only of how much CPU time on average a query took, but how much time was it waiting and on what kind of wait. So you can answer questions now to say, oh, for a given query that was really one I'm trying to tune, how much time did it spend waiting on page I/O latching or blocking or transaction log I/O or something of that nature? Really, really fantastic stuff. SSIS scale out. You now have the ability to take SSIS in SQL 17 and scale it across multiple clients from package execution to get full scalability of running an entire package. And then how about machine learning services? We had our services we added to Microsoft SQL Server 16, and we did a really amazing proof of concept and an actual demonstration with a customer of 1 million predictions per second. We've now added Python support. And what's very exciting, and they've got a great demo at the booth downstairs, is something called native scoring, where we have a built-in T-SQL function called predict, where you can do native scoring prediction inside the SQL engine and get a boost in performance for your machine learning algorithms. And then finally, column store indexes and enumerable TP just keep getting better. We continue to enhance and make incremental changes to those technologies with each release of SQL Server, and we're going to talk more about those today. I have this contention, this is just my contention, that out of the box, installing SQL Server with no changes we're actually pretty fast. And not just fast, we keep you online with things like online indexing, backups, alter tables, and consistency checks. You know, I like to think it this way. We have a highway, an interstate in Texas, I'm from Texas, where you can drive around the city of Austin, because it's got bad traffic in Austin. So you can go around the city on this big, massive interstate and drive like 85 miles an hour. And I've done it. I've tried that, 85, maybe 90, a little bit in my Ford pickup. And I like to think of online checking to be like, I'm flying down that road, driving as fast as I can, and I got a pit crew while I'm driving, rotating my tires, changing my oil, refilling my fuel tank, all while I'm online. And so we have a big belief that we try to provide you online operations to keep your engine tuned while you're running the application. And in SQL Server 2017, we've introduced a new feature called Resumable Online Index Rebuild. So imagine a scenario where you kick off a fairly large index build on your system, and you realize maybe there's a degradation in performance that it's causing to the system, a slight degradation, but you don't want to have. You didn't intentionally mean to kick it off. You have the ability now to pause the index build and then come back at a later time and resume exactly where it picked off. So if it started and it was 30% finished, you can leave it at 30% finished, and at any point in time come back and then resume that. And I've got a nice demonstration to show you that. And then a lot of people, when I talk about the SQL Server engine, are not really aware of what do we have built into the actual product to make things fast out of the gate. Things like buffer pull ramp up to when you start reading pages in from disk, we actually get more aggressive, depending on how much memory you have, to pull in other pages of the database so that they are available to you when you need them. Things like read ahead as well. But we partition everything in SQL Server. We're big into partitioning to get scalability. So a lot of the things that we do inside the server are automatically partitioned by NUMA and by CPU and NUMA nodes. And then SQLOS scheduling, we've got a specific SQLOS schedule that runs on top of the operating system that makes smart decisions to minimize operating system context switches. All of these things and other things that I've got listed here are things we do inside the engine. We parallelize everything. You know, maybe you've seen parallel queries that you run in your system that could sometimes be a thorn for you, but everything we try to do, we try to run in parallel. Things like bulk loads or recovery or even logging. We have multiple log writers, index builds, backups, consistent check stacks, you name it. Everything that we have, we try to consider, is it possible to run those in parallel on your system to achieve scalability for the needs that you have? And all these type of things that you see right here, you probably don't even realize that are running behind SQL Server and that have the ability to give you a boost in performance. So let's do something. Let's do some fun. Let me move over to my demo machine. Have any of you guys heard of this tool called HammerDB? Maybe you've run it before. It's an interesting little benchmarking tool. I really encourage you guys to take a look at it. It's an open source tool that you can use to run things against SQL Server. So my goal on my laptop right here is to get 1 million transactions per minute on my laptop with this tool. And so I've got this configured now to run against a TPC-like workload, which is a benchmark-like workload for OLTP transactions. I've got it configured on my SQL 17 instance running on my laptop. This laptop, by the way, just to be clear and transparent, is a pretty beefy laptop. It's got 4-core single socket hyper-threaded, so it's 8 CPUs. It's got 32 gig of RAM, although I'm only using 16 gig for this demo. And it's got a pretty fast SSD drive, a PCI NVMe SSD drive. So I'm going to kick off this workload. First, I'm going to go, and I'm not going to go all the steps of how you run this tool, but they're pretty simple. I've got them listed in my demo here. But basically, I'm going to go through and make sure I'm connected to my SQL instance. I'm going to do what's called load the client driver that's going to run these threads. I'm going to run like 25 users at once trying to run this workload. I'm going to create them, and then I'm going to kick it off. I'm going to first make sure that my little graph here that's going to show you the numbers. Okay, it's starting off here. That's not 778,900. That's not bad. Out of what? 1.2 million right out of the gate. So 1.2 million transactions per minute. I'll get back to that in a second. But what if I want to actually go and rebuild an index online? So here I've got an option now with rebuild online, resumable on. I'm going to go rebuild the index online. I'm going to kick it off. Now, if I notice over here I start getting a slight degradation in performance, I can come over here and pause the index. So I'm going to come over here now, and I'm going to pause it. And then by running this particular catalog view, I can see that my index was paused. And if I go over here, I can see percent complete. Let me zoom in and show you that. So here's the percent complete, 56% complete. So now, if I saw that my index had an issue, I can just pause the index, come back, and then if I decided later that I didn't want to actually if I wanted to continue to resume the index, I can come back here and I could continue rebuilding it. And if I run it again, it's just going to pick back where it left off. Now you get actually disconnected when you pause an index. It's almost like disconnecting the index, and now it'll go finish its operation. Now, somebody asked me, I was showing this at the booth yesterday, and somebody said, like, does this even matter? I mean, why would I even run this thing? Why, does anybody even really care about it? Well, it's actually a great demonstration of SQL Server capabilities out of the box. This particular workload is running a combination of insert, update, deletes against SQL Server, and I've not made any configuration changes to the server on my laptop. So if you want to just test to see how capable is SQL Server, how capable is it running a workload on my specific system, this is actually a very, very good tool. In addition, I wanted to show you today, this is a preview of Management Studio, the next version of Management Studio. And I know a lot of you use SQL Profile. We have added a new option here now called XE Profiler. And if you click right here, I'm now going to get an actual standard live view immediately of the workload coming in, just like you're running SQL Profiler. So now when you run Management Studio out of the gate, very simply, you can come in XE Profiler and get a live look of what's running. Now, if you see over here these commands called SP execute, you're like, what is all this stuff? I don't see the queries. What you could do is you could come into SQL Server, and instead what you could do is you could turn on Query Store. And that's what I'll do. I'll turn on Query Store. So I'll turn on Query Store, and while this is running, Query Store is starting to collect now the queries that are running against my system. And I'm still over cranking away, running my transactions. I'm down to about 800,000 now because I'm tracing this workload a little bit, so it has some slight hit on it. But if I come now back out of TPC workload, I now get a Query Store report that I can look at what queries are these prepare and execute. This is a prepared workload where they prepare and execute queries very often. So I'll come down here. Let me refresh. Now with Query Store, I can see the top resource performing queries. And here you go. I can now go check and see what queries are taking those time. So I've just demonstrated a scenario where I was running about 1 million, but I turned on Query Store and turned on live tracing, and I can still maintain almost that type of workload. All running on my laptop with no configuration, no changes to SQL Server. I'm sorry, but that's pretty stinking amazing. I think it's pretty cool. So, and I really think what I'm going to do is I thought about this before my talk today. I'd like to do a blog post about how I did this, and I think I'm going to do a tweet contest. I want to see who's going to get the fastest HammerDB workload numbers, either on your laptop or on your server. So I think it'd be a fun contest, so maybe I'll do that. By the way, as a teaser, in that blog post, I'm going to show you how to use HammerDB with impermeable TP and how I actually configured HammerDB properly with index design to actually get 30% faster than this workload I'm showing you right now. Okay, let's stop all this. By the way, in case, if you're in the front, you maybe can hear the smoke coming off the laptop. The fans are kicking in a little bit, so. All right. Pretty cool stuff. Let's go back to the deck. So SQL Server, as I said, may be faster than you actually think. And I'm here to tell you today that we are fast on Linux. #1 benchmark for a 1 terabyte workload on TPCH, non-clustered. We did that very early on out of the gate. Running on an HP server, using Red Hat Linux, right out of the gate. It's just SQL Server. It runs just like. And there's quite frankly, the configuration that the benchmarks that the HP guys did and Red Hat did and we did for that benchmark is not much different than how we configure TPCH benchmarks for Windows as well. So the configuration we did was pretty much the same. And containers as well. I've actually run containers, Docker containers, using a similar type test on HammerDB and seen similar numbers even running on a Docker container. Analytics at warp speed with column store indexes and impermeable TP. We're going to talk about those. I've got specific slides to go over those technologies. Yesterday I was at the booth and I was showing demos of column store, and it was amazing to me how many people still really don't understand, which is not your fault, about how impressive this technology can be for read workloads. What about this one? Write log waits equals 0 with persistent memory. We introduced in SQL 16 and 17 the ability to use this new technology called NVDIM with persistent memory so that the transaction log itself will first be copied in memory to a persisted memory cache and then lazily written to the transaction log later. And so the interesting story here is that if you've ever seen this write log wait type in the DMVs that you use, like DM exec requests, and you look at wait time, normally that shows a number that you look at, like 1 or 2 or something. That's milliseconds, right? Well, we were seeing 0 all the time in our tests with persistent memory, so I thought it was a bug. Well, it wasn't a bug. It was the fact that we were getting microsecond latencies with this technology. So how about microsecond latencies for your transaction log workloads with persistent memory? And you're going to see persistent memory as a technology in the near future. It's going to become more and more popular as a storage device, as an alternate storage device where you can copy things in memory to it, and it's totally persisted with a complete power backup. You can load data fast in parallel with minimal logging. We introduced in 16 and 17 the ability to do parallel and minimal bulk logging into a table with a clustered index without that crazy trace flag that you've been using for years. So that's all by default now. And I've seen amazing results with using parallel bulk logging in a SQL Server. And then finally, we know how to tune Linux for maximum performance. Out of the gate, we're fast. But we've got people on our team that are experts on Linux, and I've worked personally with them. And you're going to see, as we announce general availability of SQL 17 for next Monday, you're going to see in our documentation light up a best practices configuration guide for Linux, where we have specific steps and tuning parameters for a Linux operating system that you should be using to get maximum performance. So get ready for that Linux guide. You'll take a look at it. It's not all that heavy. It's not like there's 100 things in there. It's actually a very, very small set of things that you should consider running for SQL Server on Linux. So what can I tune for better performance? I spent some time actually talking to some people in our field, in our product team, and our support team, and our customer advisory team. I'm like, and MVPs, what do you normally tune for better performance? And this is kind of the list I came up with of common things that people do to get faster. Now you can take a look at this list and you can say, okay, well, how do I do all this stuff? Well, there's an amazing amount of information. We have one of the best communities in the world, in my opinion, in SQL Server. We do. We have an amazing community. In fact, sometimes I'll admit to you, when I want to get advice on what to do, I just go to the community because people have such great experience using our product. And some of these things are choices that people in the community have made, and they document how to do. What kind of index to build? Should I use partitions? How do I manage statistics? Should I use auto-update statistics or manage them myself? People often run into situations where they should be parameterizing queries instead of running just ad hoc queries that are not parameterized. What about max server memory and max degree of parallelism? Very contentious debate in the community about how to set those, but the facts are those are two settings that are commonly used by customers to tune and get the best performance of SQL Server running their environment. Another common was multiple tempDB files to partition allocation structures, not just about I/O, but to partition SQL Server that when you run a lot of tempDB workloads, what should you use? And there's great advice out there. The most common thing I always tell anybody is start with 8, usually because you have more than 8 CPUs. Start with 8, and then add by 4 until you don't get any better performance. I mean, literally that is the way. I've seen customers try to put hundreds of tempDB files, and really sometimes actually are hurting themselves by doing that. So be careful on how many you do there, but start with 8 and go by 4. Reducing the size of transaction log to avoid auto-grow. The reason why that's important is because instant file initialization, which is a feature we have for SQL Server for your database file, doesn't work for the transaction log. And so, and I ran this when I was doing testing of some of these benchmark tests on a high-powered machine in our lab. I was running this workload, and all of a sudden, CPU went to nothing. I got no CPU time on my machine when I expected to be hitting all processors at 100%. I'm like, what's going on? And I went and looked at SQL Server, and sure enough, a massive auto-grow was occurring of the tempDB log. So the transaction log, right-sizing the transaction log to avoiding auto-grow, even though auto-grow is nice so you don't run out of space, but that is one of the most common things you should take a look at to avoid performance problems. And then target recovery and automatic checkpoints. The defaults are nice, but it could be for maximum performance that you want to sacrifice a little bit of extra recovery time for better performance. And so take a look at those kind of type options. And then finally, one of the ones that seems like, to me, it can be a little bit contentious, but not used enough, is read committed snapshot database option. So read committed being the default, and so if you want to take a look at the ability to avoid blocking problems, this is one you should definitely take a look at. And in fact, this is the default on Azure SQL Database. So if you install a database in Azure SQL Database, this is the database option you get by default. What about the operating system? What are the most common things kind of in the operating system people look at? Well, there could be several of them, but for Windows specifically, these are kind of the 4 things that I've seen people look at. Number 1 is locked pages. I'm here to tell you today, for a Windows system, there's no reason why you should not use this option. You should absolutely turn on locked pages, in my opinion, on an enterprise production workload. When you do that, though, you need to appropriately size Mac server memory to a value to give enough room for the operating system. What about instant file initialization? Another option, which in SQL 16 and 17 is now just a little checkbox that you can pick when you install SQL Server to have that option. And again, not for the transaction log, but for the database file. So now, an auto grow of your database file is a no operation, because instant file initialization allows us to create a file or grow a file in the matter of the snap of your finger. And then finally, a couple things. High performance Windows power setting. Has anybody ever run into a situation where this was not set on your server and then you ran into a performance problem? And I got that from the support team. The support team told me that one of the number one things they ask customers when somebody calls them on a major performance problem on a server is, do you have this setting on? And as it turns out, no, they didn't. They did not have it set to high power performance in Windows. And then finally, maybe it's obvious, maybe it's not obvious. But when you take a look at the benchmarks, you take a look at people that have high performing servers, they're always putting the data and log for their database and transaction log on some disk that's not the operating system disk, somewhere else in their system. And even some people decide, and it gets in a fairly massive debate, should you put the data and log on different devices? Sometimes it depends how your SAN's configured, right? Maybe it's striped already so well in the back end that it doesn't matter whether the data and log on are a separate device. Most people I've seen, and in the benchmarks they do, the benchmark folks do, our vendors, our partners, Lenovo, HP, and some of those folks, they always separate data and log on different striped drives, but definitely not on the operating system disk. And then finally, Linux Best Practices Guide for Performance. As I mentioned, if you take a look at that, and this is a hyperlink, by the way, so quick funny thing. If you get this deck today and you click on that link and you get a 404 page not found, that's because it's going to light up Monday. So this is specific guidance in our docs that will light up Monday. And if you go take a look at it, there are some specific settings for SQL. There's a few settings for SQL Server that make sense on Linux. And then there's a few settings on Linux that actually make sense for SQL Server running on Linux. There's about 5 or 6 settings on the Linux side, and there's a couple settings on the SQL side. You could not set anything and run pretty well out of the gate, but if you want to maximize performance, please take a look through that guide. I'm really interested to see your feedback if you're running on Linux with SQL. We've actually reviewed this with our partners like Red Hat. We reviewed this within our team, our Linux experts. Feel pretty good about what we said, but I think we're going to continue to evolve that best practice. As more people deploy on Linux, we'll see how well that performs over time. So let's talk a little bit about column store. Again, I mentioned yesterday in the booth, some folks came down to me. Great questions, and I love talking to folks at the booth. By the way, just a quick little tip. The demos that I'm doing here are at the booth. So if you come see me at the booth, and I forgot to mention Thursday, I'll be there all Thursday morning. So if you want to get a one-on-one demonstration of these demos at the booth, please come down and see me. And one of the ones I'm going to show you is on column store. And I'm here to try to tell you, I'm a practical guy. I'm a pretty simple, practical person. I got a lot more people at Microsoft far smarter than me, people in the community far smarter than me, so I try to simplify stuff. And I asked myself, you know, why is this column store not getting used as much maybe as it should be? And when I ask customers about it, they're like, yeah, I've heard about that, but I'm not sure if it makes sense. So here's how I break it down. Number one, we use compression when you build a column store index. And as it turns out, it's better to compress data by columns across your table, like a vertical column, than across rows. So we have compression in SQL Server already, row compression and page compression. But it's actually more efficient to compress all the column values together versus horizontally across the rows. And we compress this both on disk and in memory. In the demo I'm going to show you, I just out of the gate got 2x compression, but we've seen customers get up to 10x compression using column store indexes. And then if you use the archival option, even more compression than that. So better data compression using column store. Second of all, we have something called column elimination. All this data, as I said, is compressed and stored in columns. These are called segments, okay? And in these columns, what's interesting about this, as you go get data, it's often in your application, or it's pretty rare, excuse me, your application, for you to run select star, right? You can do it, and your developers probably do it, and your report folks sometimes maybe do it, but it's pretty rare that you just do a select star. Usually pick some columns you want to access in your table. So we have this concept called column elimination. Since we're storing data by columns, guess what? We can skip going after the data for columns you don't care about. We just go after the columns of data that you do care about. So vertically, we're only getting data that's stored and compressed this way for the columns that you most care about in your query. Second of all, we have natural built-in partitioning with column store indexing, with clustered column store indexing especially. So basically, if you actually organize your data in a way that go after, and you sort it in a way that is most common to the range queries that you do most, the most common in a warehouse is date, right? So if you actually sort your column store data by date, and then you start running range queries on that date, SQL Server with column store indexes can actually skip areas of the column store index that are not part of that date range because we store metadata about the date ranges and where they exist in the column store. That we call that row group elimination. So column elimination this way, row group this way. A natural partitioning concept, and you can even combine this with table partitioning to even get better performance. And then fourth, we support something called batch mode execution. The concept of operator process in groups of rows. So when you see operators now in a SQL Server query plan with column store, we can process things in batches instead of a row-by-row operation. So all four of these together are the most simplified view I can give you of why it matters to use this technology. And here's my take. If you have a mostly read workload, and what I mean by that is maybe you do a lot of inserts or refreshes to your data, but you don't do a lot of updates and deletes to your data, column store is perfect for anything over 1 million rows per partition. You don't even use partitioning, just have a table over 1 million rows. Using column store index actually is really effective. And I've found very few situations where it doesn't work well. So I'm really telling you, and I'm asking you to take a look at your system, and if you fit something like this, just use it. Just try it and see how fast it can be. And I've got a nice demo to show you kind of the power of column store and what it can do for reporting users in your environment. What about IntermLTP? It's really unfortunate we called it this name because it's more than just about OLTP. And in fact, look at this number, 1.2 million batches per second with schema-only table. So we have a customer that had a scenario where they needed to cache data. So in other words, it was data that when SQL Server starts up, they load, and then they reload it every time. So effectively, they don't really care if it gets lost. So a schema-only data, which is in memory and not logged and not persisted, is perfect for them. And they were able to achieve 1.2 million batches per second. Just to give you an idea what that looks like, my 1 million transactions per minute, in HammerDB terms, that's really measuring batches per second, by the way. It's not measuring transactions. It's measuring batches per second. That's about 16,000 batches per second. They really get 1.2 million batches per second using this technology. And really one of the things that people miss about this technology is they just call it an in-memory technology. And yes, it's in memory, but it's optimized access to data in memory using a very efficient no-locking algorithm. And it really shines with concurrent workloads. If you're going to test this technology and you take a single user running an insert statement and compare it against a table that's not using this with a single user, you're probably not going to see much results, right? But guess what? When you start pumping up multiple concurrent users, that's where it really starts shining because you avoid all the latching and other types of synchronization and locking that occur when you're not using this technology. And it's great for OLTP, but consider some other things like staging data. If you're staging something. In fact, this 1 million predictions per second, if you go out and look at the blog post and the details of what they did, they use this technology to stage data in SQL Server to actually achieve some of the numbers they were looking at. Their predictions were stored actually in an IntermLTP memory optimized table. And then what about this last one? No more TempDB. Table types are easy. If you have applications using table valued parameters, which require table types, you can simply switch to using this technology and avoid TempDB by just adding a syntax with memory optimized to your table type definition, and instantly you're using this technology. I've had several customers that have moved to this, starting with SQL 16, for any of their table type applications. And then just to let you know about latency, if you start running this and start running into situations where the performance is not what you expect, Bob, I didn't get anywhere near 30x, and you're like, why? The first thing I'm going to ask you is, what is the transaction log latency of your workload? So if you use a durable memory optimized table, we still have to log at commit time. So if you have a very slow disk for transaction logging, it's going to slow down the overall ability to get fast with this technology. So find a fast disk for your transaction log when you're using this technology. You know, our customer stories to me kind of say it all. It's not just me saying this. And these are not just things that we threw up on a marketing brochure and these guys just gave us great, waving stories. They actually really achieved some of these numbers. Look at DV01. This is a customer using Postgres on Linux that wanted to desperately move to SQL Server, but we didn't have SQL Server on Linux. So they made that move and got incredible orders of magnitude performance over Postgres running SQL on Linux. Channel Advisor, a customer I've talked to personally before, has used in-remote TP and seen significant reduction in overall response time to their transactions using it. And I love the quote from this last company, Fidelity National Investment Services. We didn't involve anybody. We didn't call any experts. We didn't call Microsoft. We just stuck a couple of non-clustered column store indexes and we got 20x times faster performance. They did what I said to you. Just try this and see if it helps you. And they did, and they got amazing performance out of it. But hey, let's see it in action. Let's see what it's capable of. So maybe in your environment, in your system, you're used to Power BI being a technology that your users want to use. And Power BI is pretty cool because it has this amazing ability called direct query. So you can set Power BI and say, hey, I'd like my Power BI report users to go directly against the SQL Server. I don't want to build a model. I just want them to go directly and run queries against it. But you're really afraid because you're like, my reporting users don't know how to write queries. Well, I'm here to show you a small demonstration that with column store indexes, maybe some of your fears can be eased. This is a Power BI dashboard, which is available in the demos, against some of the TPCH benchmark-like data that you see, which is a supplier-type database. And so one demo here is showing this visualization chart based on a query that comes from TPCH called shipping priority to show you where in the world do I have shipments that are delayed that I need to get faster so I can make more money, that I'm losing money, right? And if you go over here and you just refresh this particular data source, you'll see for the TPCH workload that it actually is taking some time to refresh, right? It's like, oh, that took a few seconds. That's not too bad necessarily. But what happens if I were to simulate a workload of users that are running that same query, that same Power BI report, like multiple concurrent users? How well would that one user perform? So I've got a little script over here running a neat little tool called OStress that you can download. It's a tool called RML Utilities. You can download OStress. So I'm going to kick this workload off, and I'm going to go back, and I'm going to run that again. I'm going to see what happens. And now you're experiencing a call from your report users. Hey, I'm trying to run my report to get a business decision done, and it's taking forever. This is ridiculous. Why is this happening? And you really don't want to say, well, it's because a bunch of everybody else is doing the same thing you're doing. So that's not all that exciting. So instead, what you want to do is you want to go and do what I did, which is take the same database, the exact same database, and all I did is build a clustered column store index on top of the two biggest tables called line item and orders. That's all I did. And I'll show you the performance behavior of that one. So I'll come here, I'll run the same refresh, and you'll see the first user is pretty fast. And if I kick off the same type of workload of multiple users, let's see how fast it is. Kicks off, and you're like, oh, that's maybe not fast, but actually this finishes in a couple of seconds, and if I run this again, it's pretty consistent. So now, I actually only took a couple of seconds to get this report with column store indexes, whereas using not column store indexes, that particular refresh could take a long time and frustrate your user base. And by the way, when you run this test without column store indexes and you run more concurrent users, it gets far worse. But with column store indexes, you get predictable same performance, even if you throw in far more users than I'm showing this demo. Another thing that you may not have seen on here, and let me pull these reports side by side, is this number in the lower corner over here. Notice this number says 16,000. That's 16 gigabytes for the database. That's effectively how big this database is. If you look over here, this number says 8,000. That's the compression I got just by adding these columns for indexes. I got 2x compression by just throwing them on there. Now, another thing that you're maybe kind of worried about is not necessarily, like maybe you built that visual for them. Like, okay, you just use this for your needs. But what you don't want to do is opening them up to doing their own visualizations, right? You don't want them to go over here and say, you know what, I want to market segment data, and I want to see the quantity of all my shipments, my parts and supplies across these segments. Uh-oh. And you noticed over here, this is not refreshing very fast, right? Because what's happening behind the scenes is it's running direct queries and scanning that entire table, doing a big aggregation against that without column store indexes. So you can see this is taking a while. In fact, it's still not even finished. That's not all that good, right? In fact, I finally finished. Here's what's worse. You get it here, and they say, well, I want a pie chart. And they click that, and we have to query it again. And now all of a sudden, now they're waiting for a delay. So every time they click one of these visuals, and to change it, sometimes we have to query the database back to redisplay the data in a different way. That's not good. So what about my column store index database, my faster one? How well does it perform on the same type of operation? So I'll bring over market segment, and I'll go over here to line item, and I'll take the quantity, and boom. That's not cache. That's actually running a query. And then I can click any of these I want, and I get instant results. So now you have less fear for your users running ad hoc type query workloads from a reporting perspective in this direct mode than you were if you were not running column store indexes. And by the way, if you're just wondering, like, where was all this running? It was running on this. So on my machine is a VM running SQL Server on Red Hat Linux, and I've got a terminal going into it, and top is showing SQL Server running. So I just demonstrated Power BI running with column store indexes with no configuration changes to SQL Server running on Red Hat Linux in a virtual machine running still on my laptop with this whole configuration. So Bob Ward continues to push the limits of laptops with SQL Server demos. Okay. So what about keeping you fast and tuned? I mentioned if you're in this audience, you're like, Bob, this is really impressive, but my performance is pretty good, pretty happy with it when I first deployed it. And then things started getting bad for me, and it caused me a lot of pain. Do you have anything for me today? And I do. Number one is adaptive query processing, built into the SQL Server engine on SQL Server 2017 into our query processor. Couple of interesting examples for you to consider here. I don't have demos for it, but a couple of examples for you to consider. Number one is memory grants. And if you've not seen this problem before, you will. The problem is that when people run queries that require sorts or hash joins, and SQL Server makes a decision to not give enough memory to those operations, what happens often is a spill to TempDB, which will show up as a symptom of an I/O completion wait type or heavy I/O to your TempDB database that you did not expect. With adaptive query processing in SQL 17, the optimizer can recognize that situation and without recompiling your plan on the next execution, adjust the memory usage to avoid the TempDB I/O spill. What about adaptive joins? This one's impressive. SQL Server has the ability to recognize a query plan that it can build where it can decide, hey, you know what? In some scenarios, a nested loop join's a good idea for you here, but in some scenarios, a hash join would be better. So let's create a new operator called an adaptive join operator where we can make that decision on the fly. So now we will introduce this new operator into your plan called adaptive join, and depending on the data input and the type of query that's being run, we can make a decision to use one or other join type for you adaptively depending on the query that's run from the system without recompiling the query plan. And there's another scenario with table valued functions as well. This is just the beginning. Adaptive query processing is something we feel strongly about. It's our query optimizer trying to be smarter to adapt to your needs as you're running to avoid you from having to do tuning to queries that are running in the system. Now, if you're in this room and you've not used SQL 16 or heard about it or heard about Query Store, I just showed you a small little demonstration of what that can do to look at query performance. And I told you that we added weight statistics to that feature. But here's something exciting what we did. The team that built this is an amazing set of engineers that in Query Store. They looked at Query Store, and they did this first in Azure. And they said, you know, there's a lot of good telemetry in here. There's a lot of great performance about queries over time, including the plans that go with those queries. And one of the most common frustrating things for customers is a query plan that changes for a query that causes worse performance. And now you're struggling to figure out, how do I fix this and what happened? Well, with SQL 16, you have the ability to go in and try to find these yourself and force the previous plan to say if it's faster. But now in SQL 17, you're going to see in a second here, we're going to actually automate and make that easier for you. And then finally, I'm a big believer in diagnostics. I used to come from the support team, and the Tiger team that is in our engineering organization is really amazing at looking at diagnostics. So anything from live query plans to adding Query Store weight statistics to this one that you'll really love, Query Plan Compare Analysis. Go take a plan in Management Studio now and right-click it and say, analyze my plan. And we'll go through and take a look at it and give you suggestions to how to make it actually faster. Like one of them is insufficient cardinality estimation problems, like statistics are out of date or up or wrong or something. We can analyze your plan and help you make decisions based on that. But what about this auto-tuning thing, this thing in Query Store you just talked about? Take a look at this graph. Imagine a scenario where performance is running pretty well for that graph, and all of a sudden then the red line hits. Performance goes south because for whatever reason, a new plan had to kick in for your query. Memory pressure kicked in, and we had to evict your procedure plan. And now you come back and run it again with a different parameter. Recognize that something called parameter sniffing, maybe you run into that before, and it's a thorn in your side. Now we have a new feature in SQL 17 that if query store is enabled, we first can detect query plan regressions and show you this in a DMV so you can see them. And then if you're comfortable, you can turn on an automation with this alter database statement so that we'll not just detect them, but we'll fix them for you. And so now with parameter sniffing, think of this as last known good. You know, us recognizing a problem you run into and saying, let's just go back to last known good and see if it's actually faster for you. And the system is smart. We'll actually detect to see if the change we made has caused any further problems, and we can even undo it if we think it's an issue. Let's take a look at a demonstration of this. This is a really fun one, and one that I actually have showed at the booth a lot, actually. So based on the Wide World Importer sample database, which I have, let's go over here. So for the Wide World Importers database, here's what I did. I actually went in there and I introduced a new procedure called, oh, sorry, Bob, Catherine, you're supposed to help me. You're supposed to tell me to switch my screen. Remember, I told you beforehand, so it's Catherine's fault. I'm going to blame Catherine. No, I should be nice to Catherine. She's going to interview me, I think, sometime today, so I should be nice to her. Anyways, here's a procedure called report that I added to this Wide World Importer sample, okay? And if you notice here, it takes a parameter, an integer type, and it's doing like an aggregation, trying to find an actual average price on my orders based on a certain package type. Not atypical, right? Somebody just wants to find information from the database based on some known value. So it takes in this parameter, and so I've added that to this demo, so let me go ahead and run this. Now, let me carefully walk this demo with you. So this is going to use query store, and when you see a procedure like initialize, that's just kind of clear the environment that I had. Now here's what we're going to do. We're going to run that stored procedure in a loop 50 times. Now the procedure itself, it's not a big database, right? So this thing, each execution doesn't take very long, but the totality of 50 times is about 7 seconds, I think. Let's run it and see what it says. And one thing you can pay attention when you run this demo is you can see how fast the results window shows the results coming across the screen. So 6-7 seconds. In fact, it finished in, let's see here, 6 seconds. So let me now introduce a procedure that I've built for this demo called regression. And what is regression doing? It's doing a DBCC free proc cache and then running that same procedure with a different value of a 1. Now, why did I do that? Well, it simulates what might happen in your environment. You might have a scenario where, again, because of memory pressure, your plan for your procedure gets evicted from cache, unbeknown to you. Some other user comes along and needs a 1, not a 7, for their package type. And guess what? A different query plan is built for everybody now based on that parameter. That is classic parameter sniffing problem. So I'm going to run this. And I'm going to run the workload. Now, I'm only going to run it 30 times, not 50 times. And you can see already, just from the way the results started coming across, that this is slower. And in fact, it ends up being about twice as slow. This is so common. In your environment, you may get a call at a time you don't want, maybe at this conference, somebody saying, hey, everything went slow. It was great. Now things have gotten slow for me. What am I supposed to do? So when query store is enabled in SQL 6.17, we have this new DMV called DMDB tuning recommendations. Don't be afraid to look at all the JSON syntax there. This query is in the docs. The reason is that this DMV stores the recommendations in a JSON format, not XML. So we're going to shred that to see it. And if you first run this, you're going to notice here a couple things. And this is the big thing right here. The average CPU time changed from 68 milliseconds to 308 milliseconds, almost like, what is that, 5 times slower, right? So this is a background process that's looking at the query store saying, oh, this is 5 times slower. I'm going to tell you about this. This is pretty significant. And by the way, I noticed a change in query plan because the query store has a history of this. So there's 2 things we noticed. We noticed the CPU time got really worse for a new plan that came in the system. Now, why do we pick CPU time and not duration? Does anybody know? Why would we not pick duration? Because I/O and other things in your environment may be volatile, right? May be volatile in your environment more than CPU. Like if you had like heavy disk I/O that just showed up as a blip, it may not be a good idea to kind of go to a different plan or tell you a problem. But CPU time is typically pretty constant, so a CPU regression is typically what we're after here, and a query plan change. And if you look over here in this part of the output, we say here that the state is active and automatic tuning option not enabled. This is what this means. This means we've recognized the problem, we're telling you about it, but we didn't do anything. So what do? You got called here at the conference, you're like, what do I do? Well, we have an answer for you. You can come over here, and we're telling you that if you'll just if you'll trust us and run this stored procedure, you will fix your performance problem. You will go back to the fast query plan and get the performance you need. So just do that and trust us and you'll be good. So you're like, you get a phone call here, like maybe it's your session, maybe people walking out right now got the phone call, right? They got the phone call, they're out there like, oh, I gotta go fix this, and they're leaving so they miss this demo. So they see it and they fix the problem and they can come back in and finish the session, all life is good, right? Then they go figure out what happened afterwards. But I have a different possible solution for you, even better. So let's go clear everything and run this again. Whoops. Let's clear it. Okay, now what I'm going to do is instead, I'm going to turn on this option called automatic tuning. I'm going to turn on automation where instead of us recommending, we're actually going to try to correct your problem for you. So let's go run the repro all over again. Let's go run the 50 users. They run really fast, 6 seconds. I'll run the regression again. And now again, my 30 users are going to be slow. Now what's happening is a little different. Not only is the background processes recognizing this problem, but they are going to take effectively what was in that stored procedure and say, I'm going to do it for you. So you're not going to get called actually here in this conference unless they say, hey, we had a blip in performance, but it fixed itself. So if you run this again from this query, you're going to see a difference here. You're going to see now it says verifying last good plan forced. So what that means is that we actually went and made a change and forced back that plan. So when you run this again, you're back to where you were. So this could be a call in between a break where somebody said, hey, you know, actually I was going to call you, things were slow and it fixed itself. What did you do? Like, were you on your phone, you know, doing something? And you're like, yeah, I was on my phone. I was in the talk and I actually fixed the problem. Now, how can I see that we did that? This is where Query Store and Management Studio come nice. There's a report called Query with Forced Plans. And if you run this, oh, wrong database. Here we go. This is showing you the two plans. This right here was the fast plan. Here was the slower plan, but the little check mark right here indicates we forced it for you. If you would have manually forced it, you'd see the same thing. But we did it for you. So really amazing technology. Works in SQL Server 2017. So there's two modes. The recommendation engine is built in by default if Query Store is enabled for your database. We use that rich telemetry. Or if you turn on automatic tuning, we will actually fix a problem for you automatically. Pretty cool stuff. Okay. Great, we got about 20 minutes left. So it's my contention that SQL Server is the fastest database everywhere on the planet or in the cloud. Whether it's your laptop, your desktop, your server, now on Linux, now on containers, on Windows, we're pretty fast. And we got some of the data to back it up. We have record-setting benchmarks on these systems, both TPCH and TPCE. And you may ask yourself, these benchmarks matter? I mean, who creates this stuff? Are you guys just making this stuff up? Are you fudging these numbers? Are you doing something in the server? First of all, there's a pretty serious TPC council that doesn't allow anybody to fudge anything. They're very serious about it. Second of all, you may go in and look at these actual specifications, and I think an actually really cool blog post that I could write is how to unpack these. Like, what do these actually do? So TPCH is all about analytics. And if you take a look at the schema that I showed you there, it's a little outdated. It's not a star schema, a snowflake type schema, but it does represent, if you look at the query workloads that run against that, they're all typical things you see in your environment for analytics. It's all about aggregations, right? Summing, averaging, sorting. And so those benchmarks matter. And so when you see a number like this, 1 million QPHH, right? Like, what the heck does that mean? That really tells us the ability for SQL Server to handle a couple of things. One called a power test, where we take 22 queries of these in a massive database and try to run them serially and see how fast can we run that one set of queries representing a a given user's day. And then we also see concurrently how can we do that when you actually run these things in the sequence. At the same time, you're refreshing the database. So when we get some of these numbers like that, they actually matter. And actually, some of these benchmarks, we're pretty serious about making sure that we take advantage of the latest hardware. This TPCE benchmark done by Lenovo with Windows was actually done with Intel's new Xeon Scalable CPUs, which got some amazing type processing power functionalities that we took advantage of in using this benchmark. And then I mentioned this persistent memory concept. Well, get ready for persistent memory unleashed. I mean, this is a new technology that right now, today, in commercial market form, is a fairly small size. And to be clear what this looks like, these are actually, they look like memory modules you put in your computer, but they're fully battery backed and have a power source to them. So what's really amazing about today in both Windows and Linux is that you have the ability to go in there and as an application detect one of these drives as a special drive that you can copy your memory bytes to it, and it almost acts like a memory copy capability that could be used for I/O purposes. So as you see larger and larger of these type of technology drives, get ready for storage now being an interesting concept, faster than what you're seeing today for the fastest SSD drives in the world. And maybe you're today needing a warehouse. You're like, you know what, I do need a warehouse. I don't have one. I need to build a data warehouse, and I want to use SQL Server to do it. But I don't know how to set all this stuff up. Bob, you talked about this stuff running out of the box. That's interesting. But I don't know when I would apply column store. I'm not sure how I would configure this. I don't know how to configure the hardware. We have something called Fast Track. Maybe you haven't seen this before. This is a partnership that we have with top hardware vendors where you come in and buy a packaged system of the hardware and SQL and the operating system installed, pre-configured to maximize a warehouse type scenario. So take a look at that. There's a link to all the different offerings that are out there. And what about Azure? You didn't say anything about Azure. If you go down to the booth and see the same demos I just showed you, they're all running in an Azure VM, both an Azure VM in Windows and an Azure VM in Linux. But you may think that Azure VMs do not have the capacity that you need. Well, what about the M series? 128 CPUs, 2 terabytes of RAM, 160K IOPS with 64 disks. That ain't bad. That is actually something you potentially could use to run a pretty high-powered workload with SQL Server in that environment. And then I mentioned about scalable, readable secondaries and available groups without a cluster. Be clear about this. This is not a high availability solution. This is the ability for you to prop up a readable secondary wherever you want without using clustering. We'll ship the log bytes over to it so you can have a readable secondary scenario. And here's what's really cool. You can do it across operating systems. So you can literally prop up a SQL Server on Windows and put a secondary on Linux as a readable secondary. And if you want to do a live migration from Windows to Linux or vice versa, you can do this using this technology. And then finally, you might find this interesting. So I polled some of the best engineers that we have at Microsoft, field people, support people, MVPs, and I said, what is the largest SQL Server you're running out there? What are the biggest installations you're running? And this is the average results from this little informal poll I did. The average installation of these large SQL servers was 3 terabyte RAM and 128 physical cores. But if you're thinking to yourself, well, that's nothing, you know, can't you go bigger? Look at the limits that actually we could achieve. I actually found these documented. These are the limits on Windows and Linux. 24 terabytes on Windows, 64 on Linux, 64 sockets on Windows with unlimited cores, and 5,000 logical CPUs on Linux. SQL Server theoretically can run a machine, if you could find a machine that has that, we can run in those platforms. What about the benchmark guys? You know, do they do anything special? Is it some sort of secret magic that those guys are doing? Well, I took a look at what they were doing. I looked at some of their configuration. I talked to some of the folks that work on the benchmarks, and I found some of this you might find interesting. For TPCH, they always partition. They always make sure they load properly for column store indexes. They manage their own statistics. And so if you look at some of the list of these things on here, each one of them may or may not give you a massive boost, but together they might give you great performance. Like managed statistics, what do you mean, Bob? Well, they don't use auto update or auto create statistics because yes, it's fine and your system can perform well with that. They just want maximum performance, so they're going to manage their statistics themselves. This might surprise you. Turn off automation you don't need. What does that mean? Well, default trace enabled is something we've had around for a long time in the product. where we actually behind the scenes will write some information to a SQL trace file on your disk. If you go take a look of what's in there, it may not be interesting to you, so why just not turn it off? And there's other things that they consider as well, but they all publish it. If you look at the benchmarks, they'll actually publish all this stuff. And this one is really interesting. Client and networks matter. So when they run these benchmarks, they run the client drivers. Like, one of the things that you may not have realized when I ran HammerDB is that client driver and SQL are running on the same computer. So what we do when we run benchmarks, of course, because this is your environment, is the client driver runs on another machine that's high-powered with a very fast interconnect to the server. So if you don't think networks and clients matter, they do to the performance of your system. And then finally, I talked to the Lenovo guys who do a lot of our benchmarking and say, what do you guys do from a hardware perspective? There must be this million checklist things that you do. They said, no, not really. These are four of the things that we typically do. Number one, we make sure the BIOS maximum performance setting is on, because it's very common on machines today for those BIOS settings to be, and I'll just say this, more of a green setting, right? Which is kind of a balanced approach, which could affect the speed of your CPU. And then here's some tips they have for disk configuration. Because of the benchmark, we have to prove reliability. They do use RAID, but they separate it. For the operating system, they just use mirroring, RAID 1. For the log drive, they'll use RAID 1 or RAID 10, and they'll add disks as they need to give maximum performance, because TPCE, in this case, is the example they were telling me about. You know, the log performance is important because it's transaction-based. And for data in TempDB, they actually put it on the same drive and just use RAID 0 and spread evenly across those drives. So hey, man, let's finish off here. We got about 14 minutes left. Let's do some fun stuff. I mean, you know, Bob, this was interesting. But can you get fast? I mean, can you show something that's really interesting? So this right here is a lab machine that I have back in Redmond. It is a, let's see, it's 2 terabytes, 144 CPUs. It's not that bad. So how fast can HammerDB run? 1,000 users running against a 100 gig database. Let's create them. And let's see here how fast this can get. Got this going. Okay, here we go. Let's see. Okay, 900,000. So remember, I did 1 million on my laptop. Okay, so there's 1.3 million. That's not all that impressive. 3 million. Okay. My goal is 10. Can I hit 10? 4? I feel like I'm like in a, you know, let me have 10, 5, 5, 10, 5. You know, let me, you know, what do you call that? I'm in a auction. Thank you. I'm in an auction. 6, 6.4. Come on, man. This did it in the speaker room before I walked in here, right? Come on now. 6, 7. 7, come on, 7, 6. I don't know if it's going to make it, man. I had it working earlier. Crud. Oh, man. I don't know if it's configured. Well, back to 5. Okay, I lost a little bit here. Let's see. Give it a second. Give it a second. By the way, you know, just to you know, fill time right here. If anybody wants to come by the booth and talk about the amazing win by the Cowboys last night, you're welcome to do that as well. No booing. So. No, I don't know. I'm not going to make it. So I'm gonna get my blog post, and I'm going to post whether I actually hit 10 million or not, right? Let me show you. Oh, man. I had it at 9 at one point. Okay, not going to make it. So, by the way, one way to easily get 15 million, which I've done, is to run this client on a different machine. Oh, it hit 9, right? It got to 9? Ah, okay. I thought I was going to show it to you. I thought I was going to make it. I'll give it a few more seconds. No. Oh, man. Okay, I'm going to get 9 and take a screenshot, put it on Twitter. I mean 10, get to 10 million. And by the way, with MRLTP configured the right way, I have achieved 15 million on here. So the other thing I want to show you is that database that I use for the column store demo, which is interesting. I think I said 16 gig. You're like, come on, man, Bob, 16 gig, that's really no big deal. So I put a 1 terabyte database on this 1 terabyte machine on here as well. And I took one of the queries. This is one of the queries that runs this column store index scan. This takes us several minutes. This takes like 2 or 3 minutes to run without column store indexing. So I'm going to kick this off. And I'm going to go over here and see if oh, yeah, look at that. I can peg every CPU on that machine. I am pegging all 144 CPUs. And I think this takes about 10 seconds to run. And my friend Travis beat me, though. This is only a 5 billion row table. So this is a 5 billion row table that I scanned in 10 seconds with 140 CPUs. I think he scanned 180 billion. So I need to find a bigger machine, I think, to do that. So anyways, just some fun fun stuff to show you how fast SQL can actually be. I've got some resources for you here that are available to you. Look for a blog post coming out this week where I talk more about SQL Server 17 and performance. Also, if you've not seen the Bob SQL blog, that's where probably you'll see a lot of my blog posts coming out about how fast we can really be on SQL Server. Remember, aka.ms/bobwardms. That's where you're going to find the decks and the demos. SQLperformance.com. I always believe in propping up our communities. That's a great website. All community powered. That's not a Microsoft site. That's our community giving you tips about running SQL Server performance. Some great sessions here in the Ignite that's talking about SQL 17 and performance. I, again, will stay here and answer your questions after I dismiss you, because, again, it's going to be a mass exodus of people leaving. I really appreciate your time today. I hope I achieved what I came out and I told you. Whether you're an expert, new to SQL, developer, trying to keep things tuned, you're going to have enough compelling reasons to take a hard look at SQL 17. Take heart that SQL 16 has a lot of this functionality, right? But that it is possible to get good performance from your SQL Server. And I've given you some ideas of tools and some things you can use to actually get maximum performance from your application. I hope you really have a great time Ignite. Please come see me at the booth tonight at 5, Thursday morning. We can talk Dallas Cowboy football, or we can talk SQL Server performance, whatever you'd like to do. Enjoy the rest of your conference, and I'll stay here to answer questions on the mic afterwards. Thank you. Mic me up, Donnie. I'll take questions here from the mics. Please line up on the mics. Go ahead, sir. If you've got questions, let's use the mics first while we still have our time.
I have an old database, which we're planning on migrating up to 2016.
Okay.
Once our company releases the 26 build to use.
Okay.
My main question has to do around the
Can you get right into the mic so I can, okay.
My main question has to do around the query store with the live trace.
Query store.
Correct. So the big issues we have is can't do anything because of change control. Do these tools enabling them have zero effect? Or
Yeah.
what do I need to tell my manager when we have an episode we want to enable?
That's a great question.
How do I get through this?
That's a great question. The question was about Query Store and its effect on performance. If you saw on there, I was actually running Query Store.
No, I saw. My
Yeah.
question is the political one.
What's
How
that?
do I deal with my management and other people that don't understand this to tell them there's no effect, these things are safe?
The only
I
way
need
you
these
can really
enabled
convince
to
them, in
get
my
through.
opinion, is to show it, right? And that's interesting. You could use like this HammerDB tool or your own workload tool to say, I turn on Query Store, and here's the effect that we have in our system. We built it so it had negligible performance, just in the small percentage points
So
of your
use
actual
the
workload.
tools in the lab and
Sure.
pre-production.
Use them. I would
demo,
actually use these tools in the
no
lab and
effect.
just show them. I turn Query Store on, or in this tool, now you can see yourself the actual degradation or any impact you have.
And the 2017 builds on these tools to auto
Now,
repair.
just to be clear,
if I
HammerDB
do.
is just like an open source tool.
No, the 2017 builds on Query Store and all these other technologies
Yes.
to auto repair.
That's correct.
While 2016, we have to dive in ourselves.
That's correct. For 2016, you would dive in yourself to do it. For 17, we have the auto repair. That's absolutely correct. Thank you for your question. Next question. Please use the mics for now, and then I'll stay and answer questions as long as you want after that.
Yeah, hi, thanks. My question is, great features, but one of the problems that we have saw is when we want our developers to do performance tuning, because we have developers that really want to do that, is that the roles that has to be assigned in the DB are very high, right? So our infrastructure say, no way, okay? So which roles are now, or is it still the same structure, or we have a change in the roles in SQL and the permissions, so developers can access all these performance tuning tools?
So the question is that, I want my developers to access Query Store and some of these performance tools. How do we do that? There are specific roles set up to be able to enable that. To view the Query Store, there's specific roles. The Query Store, those reports are just based on dynamic management views. So I forgot exactly the permission required, but there's separate roles in like database owner. They're not like a database owner role. We have specific permission you can grant to see those specific type diagnostics. So you don't have to be a database owner to see some of that information. Now, you'd have to be a database owner to go and look at the schema, right? Or maybe an owner or granted owner of that schema or that table to see it. But to see a lot of diagnostics, there are separation of roles that you can use other than like a database owner role.
And to enable them, we have to be the owner, right? We have to work with infrastructure.
Yeah, so you have to be an owner to give somebody the right. That's absolutely clear. Yeah, if they don't have that right by default, that's true with anything, right?
Okay, so thank you.
Thank you. Over here.
Yeah, thank you. One question I have about the persistent memory is how would it work with clustering? Do you maintain high availability if the transaction log is on persistent memory?
The question is that how does persistent memory with clustering? And the answer is it doesn't. So if you have a persistent memory set up with a transaction log, you cannot use it with availability groups. That doesn't exist today. That's something we're taking a look at because persistent memory does have capability for something called RDMA, which is remote access to persistent memory. And so one of the things we're investigating down the future is how do we use that so we can enable that functionality, but that doesn't exist today. Yes?
Thank you.
I have additional question about Query Store.
Yeah.
It's also utilize the database space, so this the size of database. Are there any management techniques to manage the amount of Query Store?
Sure.
Maybe?
Great question. The question is that Query Store is stored in the database.
Yeah.
So how do you manage that space? Well, first of all, there's a maximum size. So you can configure what is the maximum size I want this to take place. Now, of course, if we hit that max size, we have other parameters that are going to roll off older data so that you would have a rolling effect, right? So that's the first point. The second point is that we have something called capture mode. So capture mode has two modes. One's called all and auto. All is capture everything, okay? Auto is only capture the queries that are really relevant, like the most expensive ones. So you can minimize what we store by using that functionality. The other one is something called a statistics interval collection. So Query Store works on an aggregate basis. We are going to store information based, by default, on how many queries run over an hour of time, okay? You can modify and change that, which would then change the amount of data that gets stored actually in the database. So there are several different knobs and tuning parameters that control how much gets put in there, and then you can control actually the maximum size of what would be stored in that functionality. Does that make sense?
Yeah, thank you.
You bet, no problem. Next question. You're up again.
I'm up again. It's my lucky day. I'm asking this for a friend, and I'm not joking about that. I don't know actually what the K startup, lowercase k startup flag does, but he wants to know if
Which
that's going to become
startup flag?
the K, lowercase k is in
Lowercase
kilo.
k.
If that is going to become part of the standard setup or part of the UI.
The question is that what is the lowercase k startup parameter for SQL Server?
And if you don't mind, tell me what lowercase k stands for.
I will. That's the question. And lowercase k controls throttling of checkpoint processing for standard checkpoints. So there's a couple of thoughts there. One is there's other ways to control checkpoint throttling other than -k. Now in SQL Server, there's altered database options to control that throttling. Two is another option is to consider using indirect checkpoints, which, see, the problem with standard checkpoints is that a lot of times people see a huge burst of I/O activity from a checkpoint operation. Like a massive burst will occur, right? With indirect checkpoint, it's more of a smooth I/O pattern where we don't wait to give a huge burst to the disk. And -k is one way people use to throttle what that burst looks like. So you still can use -k, it's fully supported and documented, but there are other ways to do it. An indirect checkpoint might be a better option so you can even avoid having to use it altogether. Does that help answer your friend's question?
I think so, yeah. Okay.
And then again, if that doesn't, have an email me at bobbward@microsoft.com.
Okay. Thank
Yes.
you very much.
Thank
Sorry.
you. I have a question regarding the archiving of all data inside the table.
I'm sorry, what was it?
Archiving of all data inside the tables. So right now it's mostly done by partitioning of the tables, right? Moving the...
You're partitioning your table?
Yeah, moving the old data into the file groups on a lower tier storage kind.
Okay, you're switching partitions and moving them off to other storage.
Correct.
Okay.
So some of the storage vendors from years, they have something called auto-tiering, right, for the files, where they move files based on their access to cold storage or hard storage.
Behind the scenes?
Yeah, behind the scenes.
Okay.
Do you guys plan something like this in SQL? I saw some really good stuff in 2017 coming, but it's still not there.
Yeah, we don't have any automatic process to do what you're talking about. What we provide is what you're talking about, right? Yeah. Is this ability to do like partitioning where you can decide where these partitions are stored, and then they could be on different cold storage devices. We do have something called Stretch Database. Maybe you've heard of that technology. That got launched with SQL 16, where you can actually take cold data and have SQL Server automatically store it in the cloud. So that's a consideration for you. That is a feature we support in 16 and 17. Where if you
Let's
enable
say the cloud is not an option in this.
I'm sorry?
Let's say the cloud is not an option.
That's the only
Yeah.
feature we add for automation purposes.
I know, that's why I'm asking, do you plan to, because
Right now, I'm not aware of any plans we have to offer what you're talking about.
it seems like you guys have great tracking of the usage of the data, especially in 2017.
What you'd be talking about is us taking that stretch concept and putting it on SQL Server without the cloud. That's what
Yeah, and let's say you have a file group on a...
I'm not aware right now of any plans
cold-
we have to release that.
cold storage. Thank you.
Thank you. It's good input, though. Thank you. Yeah.
My question has to do with taking older database versions that supports COTS and GOT, SharePoint, and other applications, moving them to 2017, the compatibility. What are some of the checks and balances? Like if I have a SharePoint 2013, moving it to SQL 17, is that a compatible solution? Will it still run natively for the older version of the SQL it's on, say SQL 2008 or 2012 versus 17?
It's a great question. So the question is compatibility of like an older SharePoint database
Correct.
with the new version of SQL Server.
Correct.
So the first answer is that we need to ask what the SharePoint guys support, right? So they're an application like anybody else, and so they've tested and supported with certain versions of SQL. So that's the first, and I don't know the exact answer to your question about what SharePoint supports. The second answer would be is that anybody making a migration from an older version like 2008 or R2 to a SQL 17, absolutely stay in compatibility mode of your older database to start with. Absolutely do that. Because the newer compatibility modes will light up things like cardinality estimation models and different changes that might affect your application. So always start there, and then try to migrate to the new compatibility levels that exist with our versions. Query Store is so awesome for this, because we store the compatibility level of the query you ran. So imagine a scenario where you turn Query Store on with your old compatibility level, you measured your queries, and then you flipped over and measured again, and you can see the diff. Like, what was the change when I switched compatibility levels with performance? Because that's usually what people care about, right? Okay. You should know that a lot of the features we have, though, light up even with older compatibility levels. There's some things that don't, and they're well documented. But even with older compat levels, things in SQL 17 still work. Query Store still works, as I just showed you, right? So, again, always move compat levels, stay with what you have. That's my always best advice, and then migrate up. But for you, for SharePoint specifically, you need to make sure that they agree to support SQL 17 in that fashion.
Okay, so just so I'm clear, if I do a backup and restore, let's say 2012.
We would retain the compatibility level.
Right, so the compatibility level should still ring at 2012, even
That's
though
correct.
it's running on the SQL.
That's correct. Absolutely
Got it.
correct.
Thank you very much.
You bet, no problem. Any questions here, or? Okay, you want to use the mic there? And I'll come back here.
Oh, yeah, definitely. No.
Is there any improvement on open queries for legacy database like AS400?
Like the open query syntax?
Yes.
I'm not aware of any changes we've made in open query.
Oh my goodness.
But send me a note, bob@microsoft.com, and I'll look
I
it up
have
and see.
really
Send me the scenario,
Sure.
bob@microsoft.com, and I'll happy to converse with you what
all
that
the
is.
school developers doesn't want to move to DTS.
Okay, yeah, let me know. Okay, let's take a couple more because I want to make sure if the next presenter comes up, I'll have to leave the stage. So.
Feel free to go ahead.
Okay.
I've already had my turn, so go ahead.
Okay, yeah, go ahead.
Yeah, hello. I'll have to say hi to Steve Shaw back at work for your plug with HammerDB. But I wanted to ask.
I'm sorry, who are you?
My name's Ken. I'm with Intel.
Oh, you work with Steve?
Yeah, I work
You're
with
not
quite a
Steve,
bit.
are you?
No, I'm not Steve.
You don't
No,
look like Steve.
Steve's in the UK. Yeah.
Okay, yeah, I've actually
yeah.
interacted with Steve when I started doing my testing, so thank you.
My question revolves kind of around OS selection if you're considering SQL Server 2017. What
On
do you
Linux
see
or
as-
Windows, you mean?
Yes. Yeah. What do you kind of see as the have or don't have features? Is it trusted authentication? Is it clustering around shared storage? Is it CLR accessibility?
So there's a very easy answer to a couple of this. Number one, if you're on Windows already, there's no reason to make this move unless you need to make a move to Linux, obviously, right? If you're a Linux shop, this is a great opportunity for you. Let's say you're just going to a brand new SQL 17 deployment and you haven't picked either one, right? It's really going to come down to Linux and a few feature selections of SQL. So for example, we don't support transactional replication yet on SQL Server. By the way, we have an absolute committed goal that every feature on SQL Windows will be supported on Linux. But right now, what's really nice out of the gate is that list is pretty small. Transactional replication is one of those features. SQL Server machine learning services with R and Python are not supported yet. Those are two I can think off the top of my head. But a lot of this other stuff just works. So really, I think it's going to come, if the feature's not your issue, it's going to come more down to, is Linux a better operating system for my environment? than Windows Server. I'm not here to tell you which one is better because I think we run equally well on both, but we strive to run equally well on both systems, right?
I just hadn't seen kind of a succinct comparison list of what was in or out for.
Yeah, I mean, honestly, the major reason, guys, that we introduced SQL Server on Linux is because we have a lot of customers out there that have said, we love your product, we think it's a better price performance product than the competition, but we're a Linux shop. We need to run the Linux, right? And the DV01 customer running Postgres is a great example of that. And so that's the primary reason driver that we did it. Did that help you?
Yeah, thank you.
Yes. Maybe last question here, and then we'll...
Are there any differences between adaptive query processing and tuning between on-premises 2017 and Azure SQL DB?
So the question is about adaptive query processing on SQL 17 and Azure DB. Is there differences?
Are there differences, yeah?
No, it's the feature exists. The SQL Server engine that powers Azure SQL Database is the same engine run on SQL 17 with differences to support DTUs and additions and so forth, but it's the same.
Okay, thanks.
Thanks. Oh, you have a few more? Okay.
Yeah.
Until somebody kicks me off stage, somebody kicks me off, I'll stay here. So,
Well,
you, Catherine.
one question about the high availability for Linux. So for Windows, they're pretty good choices, right? Failover cluster instances, always on availability groups, mirroring transaction log, even the old log shipping, right?
Yeah, sure.
What is available for Linux? I mean, there's
So
no clustering.
the only thing that's not available for Linux is transactional replication. Everything else is supported.
So
Now, what we do in clustering is, because we don't have Windows clustering,
Yeah.
there's a product called Pacemaker. And if you look at the documentation, you'll use a product called Pacemaker, which provides equivalent functionality as Windows clustering to support high availability. But all the other functionality exists.
Because usually, if you look at the high availability on Linux, they will recommend Veritas Cluster Service, right? VCS.
We use Pacemaker as a product to support our
Okay.
clustering concept.
That was one
Again,
of the questions.
every feature for high availability, aside from transactional replication, works on Linux as on Windows.
So basically, what you're saying is Pacemaker is for FCIs, and what you do for the always on
Well,
availability.
you have two choices. You can use failover clustering with Pacemaker to support always-on availability groups, or you can use without clustering, like we talked about, which is not an HA solution.
which
gives
is
you-
not it's
It gives you readable secondaries.
just read-only secondaries,
That's
right?
Either one of those works.
Okay.
It really works, I promise you.
So log shipping and those things.
Log shipping works as well because we have SQL agent support.
Just the
Just transactional REPL, that's it. Yeah.
Okay.
Thank you.
Great, thank you.
Thank you.